Welcome to the introduction to renewable energy and fossil fuels. Sustainable energy, when we talk about renewable energy, it's energy that's sustainable. So it's energy that does not substantially deplete by continual use. It renews itself. It does not entail significant pollution emissions or other environmental problems. And it does not involve the perpetuation of substantial health hazards or social injustices. So again, when we talk about renewable energy, we also need to think of, is it sustainable? Does it pollute, or does it perpetuate health hazard or social injustice? So if we look at total energy, not just renewable energy, this is total energy in the world, what we can see is that in terms of primary production, so total energy produced, China is ranked #1 with 112 quadrillion BTUs of energy. When we look at nuclear, renewables, and other productions, then the US is ranked 1 with 20 quadrillion BTUs. When we look at natural gas production, the US is also ranked #1 with 28 quadrillion BTUs. Saudi Arabia is ranked #1 for petroleum, and China is also ranked #1 with 81 quadrillion BTUs in coal production. If we look at our total energy supply in the world from 1990 to 2017, we can see that the total energy that we produced in 1990 was less than 10,000. As we've moved up, we've gone over 12,500. And most of that comes from a combination of oil, natural gas, and coal, with nuclear, biomass, hydro, and wind and solar being the remainder. If we specifically look at electricity only, so not the liquid natural gas, the liquid petroleum, but just looking at electricity production, that is primarily in the world done by coal, followed by renewables, and a lot of that is hydroelectric, followed by natural gas, nuclear, and then we have electricity from oil being less common because we often use oil for transportation. If we specifically just look at the US primary total energy consumption is here. Of that, most of our energy consumption is energy that we also produce. So our energy consumption and production total energy is quite similar. But we do import some, but we export about the same amount. So therefore, we used to have a more gap in our consumption and our production, but that gap has decreased over the last 10 years. If we look at world renewable energy production, so moving to renewable energy, we can see that the most of the renewable energy production is with hydropower. And that's followed by onshore wind, which has grown drastically in the last 10 years, where hydropower has stayed about the same. Then we have offshore wind, which grown some, but is still a smaller percentage, followed by PV, which is also solar photovoltaic, has also seen a large increase, and finally with biofuels. If we look at where this renewable energy is coming from, China is the leader in hydropower, followed by Brazil, Canada, the US, and Russia, also the leader in PV. Spain is for concentrated solar power, which is a little different than photovoltaic. Geothermal, we have the US followed by the Philippines and Indonesia. Wind, again, China is the leader. And biomass, the US is the leader, followed by Brazil and China in biomass renewable energy. If we look at all renewable energy, again, by country, China is leading the way. It's almost double any of the other countries, with the US in second. And a lot of that has to do with hydropower. So when we get into hydropower, we can see that China has much more hydropower than the other countries. Wind generation is similar, but the US is catching up in terms of total wind energy by country. Finally, when we look at solar, China again is leading the world in terms of solar photovoltaic energy. If we look at bioenergy, the US and China are quite similar, followed by Brazil and Germany. So again, this is bioenergy. This is bioenergy for electricity production. We actually produce a lot more bioenergy for ethanol than we do for electricity, but we do produce bioenergy for electricity as well. And then finally, looking at geothermal, we can see that the US is above. Again, Indonesia, Philippines, New Zealand also have geothermal resources that they utilize. And then finally, sorry, is a marine technology. And again, you can see it's quite small. We're looking at 500. This is 15,000. And with when we're talking about, excuse me, marine, it's quite small. So it's 500 compared to up here, we were in 7,000, 150,000, 300,000. So basically we've doubled as we go through from hydroelectric being 1.2 million to 350,000 to 150 for PV to 70, again, almost half for bioenergy electricity, geothermal, and then finally just 500 with marine. If we look specifically at the US gets about, of our total energy, about 37% comes from petroleum, followed by natural gas. Coal is now the same as renewable. That didn't used to be the case. And the nuclear power is about 8% of our total energy load. And you can see here of the renewable energy, a lot of that is wood. So our wood is gonna be often wood to electricity. Our biofuels are gonna be wood to ethanol, which put in our gasoline. And then we also have biomass waste. Our wind is 24%, followed by our hydroelectric. And again, wind has greatly increased over the past couple of years, followed by 9% solar and 2% geothermal. So in all, the biomass is still 43% when we look at all of our biomass resources together. If we look at this change over time, you can see from 2000 to 2020, so over the last 20 years, our hydroelectric is at the top and has pretty much stayed the same. Now you notice here, this is renewable energy production in terms of electricity here. And then we see our wood energy, again, for electricity production, has been pretty consistent. What has changed is our biofuels consumptions has gone up, our wind energy consumption has gone up, our solar energy here has gone up, our waste energy is fairly consistent, as well as our geothermal. And this kind of shows the same thing, but now we're looking at the percentage of renewables, which is this red, compared to other things. So you can see this red component has gone up a lot since 2008, but we're still using mainly petroleum, nuclear, natural gas, and coal. If we look again at renewable energy as we go through, we can see again the biomass going up, the hydroelectric, but we see this great growth in wind in the last 20 years. And here we can again see as the coal has actually gone down, that's our blue, our renewables have gone up, while our nuclear has stayed consistent, and our petroleum's gone up and down, and our natural gas has gone up. And we can see with natural gas, it varies in our consumption based on summer versus winter, since many of us heat our homes using natural gas. So this is a very busy diagram, but I'm gonna break it down for us. Basically, it's looking at our different sources: petroleum, biomass, coal, natural gas, geothermal, wind, hydro, nuclear, and solar. So these are the sources that are coming in to the US economy. Many of these are going towards electricity generation. That electricity is then going to residential, commercial, and industry. But if we can see biomass and petroleum, they're not going to electricity, they're going directly into transportation and industry. Natural gas, a percentage of it is going to electricity, but then we have other percentages that is going directly for heating, residential, commercial, and for industry processes. When we look at though this total energy, our energy service is actually quite small compared to, we can see how much electricity generation we have that is actually rejected and not used. And that's not only for electricity, that's also in industry and transportation as well. This is again a different way of looking at it, but it's the same information. So again, you see our natural gas, petroleum, natural gas, renewable energy, coal, and nuclear. Again, all of our nuclear is going to electric, some of our coal, most of the coal. Our renewable energy is going to different places. our natural gas, again, going to transportation, renewable, and commercial. So it's just a different way of looking at the same information. If we look specifically at our different states, you can see here that it varies very much in our total. This is back to total renewables. And we can see that in total renewables, Texas, this is just looking at the southern states, is leading with southern region with 25,000 megawatts of electricity produced from renewables compared to Maryland with only 1,700. If we look specifically at PV, most of our capacity is over here, which makes sense. We have a lot of sunshine in the California and in this area. And so this is where we're getting most of our PV capacity, but we do also have other PV. And even up here in Minnesota is number 5 in terms of annual capacity additions. But our total output is from cumulative capacity goes actually California, North Carolina, Arizona, New Jersey, Massachusetts, and Nevada. If we're looking at biomass, you can look here that the ethanol, again, our ethanol kind of the price has gone up and down over the years, but we are pretty consistent with most of our gas stations having a 10% blend of ethanol. And we can see here that a lot of our electricity from ethanol is coming from the south, and again, that being wood. And here in the Midwest, we're getting less electricity and more of it's for ethanol, so it's for liquid fuel. If we look again, the US is leading in terms of ethanol production and is much greater than the European Union, China, and about double the capacity of Brazil in terms of total ethanol production. Again, as we look at our trends, we see that our renewables have gone up, not a lot, but we have gone up over the last 15 years, while our coal consumption has gone down. And as you can see, they pretty much have crossed each other in terms of total production. And so what we look at capacity additions. So in 2017, we added 27 megawatts of energy from renewables and from natural gas, and most of those being wind and solar. And if we look at retirements, plants that we're not using anymore, most of those retirements have been in coal, some of them in natural gas, but we can see we're adding solar, natural gas, and wind, and we're taking coal mainly offline. This is the 2017 data. But as we project out, we can see that we plan on taking more coal, again, offline, while adding capacity very much in the short term with wind, and in the longer term, adding solar and as well as more natural gas capacity. So again, when we look at our projections, we're expected to grow slightly in natural gas, almost double renewables, decrease slightly in nuclear, and decrease about by half in our coal production. With the renewables, mainly the big growth being in short-term and wind, but then that leveling off in solar PV as the capacity increasing in the coming years. But again, not all fuels are equal. When we look at fuels, when we look at, methane, coal, ethanol, glucose, we can see that the energy difference between the sources here and again, what they release at the end, the CO2 and water that gets released when they get combusted is different. So again, natural gas is much more energy dense, the energy you get per mass, than coal, and then again, ethanol and glucose, table sugar, for example. Because what we're doing with these fuels, whether it's coal or natural gas or oil or ethanol, we're combusting it. And when we combust it, it's the chemical bonds inside that release that energy. So the methane when it comes into contact with oxygen, it gets combusted and we release the CO2 and water and we release energy. So again, coming back to this mix that we are right now, we still rely most heavily on our energy mixes with petroleum. And why petroleum? Why fossil fuels? Well, it's relatively cheap in the US. It's very energy dense. So 1,700 kilowatt hours per barrel. That's a very energy dense source. So a gallon of gasoline has the equivalent of 33.6 kilowatt hours. It's easy to transport because it's liquid, we can pump it. We have gas stations and existing infrastructure to use. And coal is non-intermittent I mean, once we start the pumping, we can keep that going for 24 hours a day. And versus solar and wind may not be flowing or utilized all the time. So if we look at a barrel of oil, the significance is, a barrel of oil has about 22 gallons in it. That's equivalent, which is about 19 of that is gasoline, okay? But there's other stuff in there. And so 1 barrel of oil is the average American in about 6.6 days. And it is equivalent to the electricity that we produce and that we utilize in about 18 days. So 1 barrel of oil has a lot of energy in it. It can power a car for 1,000 miles, which is the average that we drive in about a month. But it also has other things. So we look at like the motor gasoline's about 51% of the utilized, but we also get fuel oil from it, jet fuel. We get residential fuel, we get road oil, we get lubricants, but we also get plastics and dyes and pharmaceuticals, insecticides and detergents. So there's many things that come from a barrel of oil. And how that happens is the crude oil comes in and we do a fractional distillation process where it's basically heated to a vapor. We're not going to combust it. We're just heating it to a vapor. And then we condense into these towers with trays at different levels. So this is a picture of what a distillation tower looks like. And so what happens is the heaviest stuff, C7, so this is carbon with 70 carbons in a chain. That's going to settle to the bottom, and that's going to be used as tar for roads and, sorry about that, for roads and roofing. Then again, our C20s to C70s, again, long chain carbons, quite heavy, that's going to be used for our fuel oil. Then we have our lubricating oils, C20 to C50. Our diesel oils are C14 to 20. We're going to have paraffin oil. We're going to have finally gasoline. Then we're going to have our C5 to 9s. That's going to be our chemicals and some of the plastics things that we get out. And then finally, we have our liquidized propane, which is the gas that's going to float to the top. So we're able to collect all of these things from a barrel of oil, with about 50% of it being that gasoline, the C5 to C10. But again, other products coming through. So what does this mean? It means that we have a lot of work to do in terms of renewable energy to not only look at replacing electricity through wind and solar, but also looking at other ways to replace all of these things in our liquid fuels and relying less on liquid fuels because it's much more difficult for us. We can make pretty good renewable electricity in the forms of hydroelectric, wind, and solar, but we need to have more ability to replace petroleum fuels and not just the gasoline, but all the other products that they produce. So thank you very much for listening, and I will stop the recording now.